turning that volume up. Can everyone hear me okay? I mean, you know, I first came up on stage here and there was usually there's just like a mic sitting here and I got to put it on. I'm like, I didn't see one on the table. I'm like, I know I'm an American, but I'm not that loud. So welcome everyone. Hope you're all doing good today. My talk today is So You Think You Know Redis. I'm going to be doing this as like an American game show. And you might see that I have piles of candy bars here. Don't worry, they're crappy American chocolate. But some of you, lucky few, will get some of them if you answer the questions correctly. So, but before I get started with that, there is someone here at the event. They may not be in this room. It's Thomas. What was the last name? Indra. And you're needed at the registration desk. So if you're in here, go to the registration desk, then come back and get the candy bars. So I'm going to do this, like I said, like a game show. I'm going to have little commercial breaks and everything. My boss loves that part. So let's go ahead and get started. So welcome to So You Think You Know Redis, the game show where Redis knowledge is tested and you can win fabulous prizes with your host, Guy Royse. So You Think You Know Redis is brought to you by Redis Cloud. Visit redis.com/tryfee and sign up for a free cloud database today. Act now, supplies are limited. Okay, so here's how this is going to work. I built a flow chart to explain how we can play this game. That seems like the developer thing to do, right? So, I'm going to present a question. Answers are going to be posted to Slido. So I'll be looking at Slido while the question's up. You need to identify yourself in some way that you'll know it's you when I read it out loud. If like, you know, you can put your first name or something like that. Just some way, because Slido doesn't require you to have a name. But if you put your answer in and then I have no way of identifying you as you, then I'll just go to the next one. And if there's any dispute about who actually answered the question, I'm just going to eat the chocolate bar myself. Because I need more. So, well, answers are posted to Slido. There's the slide.do, and then you put in hashtag GeeCON, which you've probably done half a dozen times already today. After that, I will look down the answers in order. If the answer is correct, then there's the decision. Is the answer correct or not? No? Well, then we'll go to the next answer and loop until we get a correct answer, in which case, candy will be dispensed. When we dispense the candy, just come on up to the stage and grab it. Walk right here, right in front of the camera. It's going to make a great video. Normally, I throw the candy bars into the audience, but then there was a lawsuit. No, actually, no one sued me for throwing candy at them, but some of y'all are pretty far back there, and I can't reach you, So anyhow, that's what we're going to be doing. So does this sound like fun? I hope so. Don't take it too seriously. I've got some of these questions are trick questions. They're going to sort of test your knowledge of Redis. But before we go into the testing your knowledge of Redis, it might be worthwhile to know, how well do you know Redis? How is your Redis? So who here has used Redis before? That should be practically all of you. How many, just out of curiosity, have used it as something other than a cache? That's more than usual, but still not many. I can still count you on one hand. When you use Redis as a cache, did you use it primarily just to store strings, or did you use other data structures? Just sort of shout some stuff out. Who used hashes or sets? Anyone? Okay, good. Okay, so we're not going to be... I've got an audience that's mostly used Redis. And don't worry, if you haven't used Redis, you won't be too far in the dark. We're going to be exploring Redis commands. We're not going to be looking at this from a language point of view. I do regrettably have one slide that has 2 lines of JavaScript code on it. So I just want to apologize in advance for that. But yeah, we're going to go ahead and get started. So let's start out with the first question. What does the Redis CLI return when you run the following commands? Set foo, quote, wavy hand, and world emoji. So hello world, right? And then you call get foo. Does it say error, syntax error, A, B, that, C, error, value is not a string. Or D, does it respond with hello world? So let's go ahead and take a look at Slido and see how this goes. So put your answers in Slido. How do I get to the answers here? Active poll. Has no one answered the question yet? That could be. Now, let me go to, I knew this was going to be fun. Come on. Well, maybe, you know what, the room's small enough. Let's just shout them out. Shall we do that? Well, no, someone raise your hand. Okay, Nicola. B. B is correct. Now, yeah, but I already know that Nicola doesn't want my chocolate. So who raised their hand second? Someone there did. You? Okay. Someone come and get a candy bar. So here, I'm just going to, go ahead and come up and get a candy bar. Someone gets a candy bar. Nicola gets to choose who gets the candy bar. That's the rule, so. Awkward. Ooh, I do. Wait, I might be eating one here. Yeah. So come on, grab whichever one you want. We've got Nestle's Crunch, Baby Ruth, Butterfinger, and 100 grand, which is not worth 100 grand. And there's stickers up here too. So yes, it is B. Yep. Oh, please do. Yeah, stickers are for everyone. So, of course, if you've used Redis for anything, you've probably used it for get and set. And so there's a get and set command. And the way it normally works is you say set key name to a value, right? In this case, hello. Or you can set it to a value in quotes if you've got spaces in there. And then you can get it. So why did we get these weird results when we passed in emojis? Why didn't we get emojis back? Well, what this really question is what kind of string encoding does Redis use? Right? How does Redis encode strings when you put strings into a string data type? The answer is it doesn't. Strings aren't actually strings in Redis. They're blobs. And so when I say set foo and I pass in 2 emojis, what it does is it stores 8 bytes of data that represent those emojis. Now, it will attempt to encode it when you pull it back, the Redis CLI, into a syntax that looks kind of like the /x, f, that sort of, here's all the bytes that make this thing up. And if it sees something that's like an ASCII character it can print, it'll print that. If it sees something that's a tab, it'll do a /t, that sort of thing. But it's putting the strings back to you in a way that you could copy and paste it and put into some Java code. But it actually doesn't encode anything that you put into it. Redis CLI itself is encoding the strings. Redis is not. So hello world is encoded with these bytes here. Here is a string with a whole bunch of white space characters in it. If you get and set it from the Redis CLI, you'll see the white space characters as you would type them. However, internally in Redis, the bytes are just stored. And in the case of our Unicode that we put in there, or our emojis we put in there, it's the same deal. And if you're wondering what the little encoding technique that Redis CLI uses, we all know this already. This is just all of the escape characters we've been using in every curly brace delimited language we've been programming our entire careers. This is how C does it. This is how C++ does it. This is how Java and JavaScript and C# and all of those languages do it. So should be very familiar. Redis is doing the same thing. Redis CLI is doing the same thing. However, Redis will happily accept binary data because it's not just text. There's no encoding. It's really a blob, not a string. And so you can shove binary data into there. So if I want to set the bytes, 4 bytes, values 1, 2, 3, and 4, I could type that into Redis CLI and it would store it as 1, 2, 3, and 4. And if I get out, it's going to encode it for me again. And this applies to not just strings as a data type, but anything that is a string in Redis. So if you are using lists to store strings, you can do this sort of stuff in the list values. If you're using sets to store strings, you can put binary data in there. Using hashes, the values in hashes can be binary. And in fact, the keys and the sets, the keys and the fields in the hashes themselves can also be binary. So if you really want to live life on hard mode, you can use binary information. You can use like an image as a key name. That's a terrible idea, but you could do it. So how do we get binary data into Redis? Well, you can do it from the command line with Redis CLI. Here I'm calling Redis-CLI. This would be easier than pointing with my fingers, wouldn't it? -x set foo, and then I redirect something in. So what this -x means here is it says, take whatever is from standard in that's been directed into my command at the end and make that the rest of the command. So this is saying set foo to the contents of whatever is in foo.bin. And then you can get it back out the same way. You say Redis CLI get foo, and then just redirect that output to whatever file you want to put it into. You can also do this from code. This is the only bit of JavaScript code I have here, but I'm sure you can figure out how to do it in Java. Here I've just read a foo.bin into a buffer in Node, and then I'm calling set and passing that buffer in. And so in the case of Java, Redis will take an array of bytes, and you can shove raw data in that way as well. So I've got a quick demo to show this off. Hopefully you've got time to get through all these demos. So let's take a look at a quick demo. Okay, so I change directory code, talks, so you think you know Redis, demos. So right here I have elvis.jpg, and I'm going to remove elvis2.jpg. And we'll just take a look at this elvis.jpg. You can see that this is indeed a picture of Elvis. All right, we're going to shove this picture of Elvis into Redis because he's the king of rock and roll, baby. So let's do Redis-CLI -x set Elvis, and type in Elvis JPEG. And it says, okay. Can you see that? Or am I in front of it? I think I'm in front of it. But let's do this here. There you go. Now you can see it up there. So now if we want to get it, we can say Redis dash, actually, let's go ahead and do this. So we'll get it here, Redis-CLI get Elvis. And you see, you get these escape strings like I was talking about before. This is all the bytes that make up the Elvis.jpg. If I want to go ahead and get it and put it out to a file, I could save it as elvis-lives.jpg. And if I do an ls here, you see we've got Elvis and Elvis lives here. Let me make this a little bit higher there for you. So we've got Elvis and Elvis-lives. They're both 124 kilobytes. They're the same size. One's dated today. One is dated July 20th. So it's been there a little while. And if I open Elvis Lives, we get a picture of Elvis back again. So you can shove binary data in Redis. Pretty neat. Just so that you can see here, I've got a tool here called Redis Insight. And we can see here, let me embiggen that. And if I click on the Elvis JPEG, you can see that it's got binary data in it there as well. So, okay, that's the first demo. How are we doing on time? I've got 35 minutes. We'll see how this goes. I may skip some of the demos, and you can just trust that they work. But I like that picture of Elvis. It's kind of funny, right? So next question. The key foo contains a string with the value of hail to the king, baby. What does the following command return? Bitfield foo get u7 1. Everyone's looking at us like, what the hell is this? Is this Redis? Yes, it is Redis. Does it return 104? Does it return error unknown command bitfield with args beginning with foo get u7 and 1? Does it return error invalid bitfield type? Use something like i16 u8. Note that u64 is not supported, but i64 is. Or does it return 72? Somebody raise a hand? Anyone got a guess at least? Yes, sir. D? D is correct. You all are smart. Come on down to get your candy bar. Good job. I need harder questions. So, what was this command? What do you think it was?
It's just some bit operation on a seventh character.
That's exactly correct. You're doing a bit operation. What you're doing, actually, you're almost correct, I think. It's what the bit field does is it's getting an unsigned 7-bit integer starting at position 1, at bit 1 in the string, hail to the king baby. So you're very close. So congratulations. Thank you. So what it does is it lets you extract arbitrary numbers from binary data. And since all the data in a string is binary, you can extract all sorts of numbers. So Redis stores the string hail to the king baby as this hex, or as these bits. And when I call bit field foo get unsigned 7-bit integer, and give it a 1 from position 1, what it does is it gets from that bit right there 7 bits and extracts the number. And so 72 is a capital H in ASCII and UTF-8. And so that's what it's doing. You can get all kinds of arbitrary and weird numbers. So this gets from an assigned 13-bit integer from position 23. And the reason I picked this one is because it's showing that it doesn't have to respect the byte boundaries. So this bit starts at the end of, or this number starts at the end of the 3rd byte, crosses over the 4th byte, and takes part of the 5th byte, and returns the number they're in. And of course, you can call get multiple times with the bit field, so I can get more than just one extracted value at a time. And so this would get these 2 numbers here, and return 7 and minus 12 respectively. So if you've got like a big blob of data out there, and you've got like a problem where I need to look at the first nibble of my data, the first 4 bits, and that will determine what I then do with, say, the next 12 bits. If you've got some sort of low-level protocol like that, you can parse these numbers out using Redis quite easily, actually. You can also change them. So instead of saying get, I can say set. And so here I'm saying set a unsigned 7-bit number in position 1 to 70 instead. And now it's fail to the king baby. You can increment them by different values. So here I'm going to increment that same number by 4. And we get jail to the king baby. I guess that's jailhouse rock. And we can do lots of bit manipulation commands. So we can get individual bits in these bit fields. So here this says get the value at bit 17. Is it a 1 or a 0? Bit 19 is a 0. So if you want to do fine grain, you can also set the bits to 1 or 0 in the same way. And so you can do manipulate individual bits. And you can do a count to get a count of all the bits. So you can go through here and say, how many bits are set high in here? And it will tell you. I'm not sure what you would use this for, but it's a thing. And you can do a bit position. Say the bit at what's the value? It says get the position of the bit that is set to 1, the first one, or you can do the first bit that's set to 0. And you can do bitwise operations on multiple keys. So you can have a key that has a blob of data in it, another key that has a blob of data in it, and you can do ands with the bit op command. You can do ORs, exclusive ORs, nots, and all the things that you would expect to be able to do. So Redis actually has a ton of bit manipulation commands. So I'm not going to demo this because I think I'm already running a little long. So let's go ahead and on to the next question. I have set my max memory policy to volatile LRU. What happens when I add something to Redis and it's out of memory? you get an error, A. B, it removes the key accessed least recently. C, it removes the key accessed least recently that has a time to live. D, it removes a random key. Anyone? Any guesses? C? Yes, that's correct. Come on up and get your candy bar. So, it removes the key that's least recently that has a time to live. So, one of the there's two settings in Redis that people never mess with that they always should. If you are, well, hopefully you are messing with these. One of them is your max memory policy. By default, it's set to, well, we'll go through the choices, but by default, it's set to no evict, which means there isn't one. It will not get rid of anything. You can set your max memory policy in your Redis config, or you can set it from Redis itself with the config set command. You can set it to, by just config set max memory dash policy, and then the policy. Policies include volatile LRU, or least recently used. This will evict, when Redis gets full, the least recently used key if it has a time to live, if it's set to expire, if it's volatile. You've got all keys least recently used. That doesn't care about volatility. It will get rid of something as long as it's least recently used. You've got volatile LFU, which sounds slightly inappropriate to say. It will evict using the least frequently used as opposed to the least recently used. So if the key hasn't been used much, and it must be volatile, it has to have a time to live. You can go all keys LFU, which does pretty much what you would think at this point. You can go with volatile random. This will get rid of any key that could be expired naturally that has a time to live at random. It just picks one. You've got the chaotic evil of key of eviction policies, which is all keys random. Just get rid of something, I don't care what it is. Any random key, doesn't matter. Volatile time to live. This gets rid of the key that has got a time to live that was going to expire next anyhow. So it sort of accelerates your cache expiration. And no eviction is, don't evict anything, just return an error when you're full. But this sort of begs a question is, how does Redis know when it's full? Right? How does Redis know when it's full? Sorry, I need to censor that photo. The answer is that you tell it. There is an option called max memory. Max memory is probably, if you're running an open source Redis server by yourself, is the most important setting that you can set, because if you don't set it, Redis will just keep consuming memory until it's gone. And it will keep consuming swap space until it's gone. And that is not how a cache should work. Yeah, I put your cache on disk. What? And so you can set your max memory. Now, I talked a lot about persistent and volatile keys. A persistent key is the default. When I add a key to Redis, it is persistent. And so many of these eviction policies will not affect them because it's not volatile, they're persistent. When you add a key to Redis, it's just persistent. It'll stick around until you delete it. Volatile keys have a time to live associated with them. Internally, it's not actually a time to live, it's a set expiration, but when you create that key, you set the time to live. So here's an example. I set the key of food with the value of bar. It is a persistent key. It will stay there until I remove it. I call the expire method. This will take a key that is persistent and make it volatile. Here I've told it to expire the key foo in 3,600 seconds, so in an hour. I can give it a time at which I want it to expire instead. So this is a epoch time in seconds. So I have no idea what that value is, but it was probably a while ago at this point. But you can specify a time or a time to live. And you can actually specify these in microseconds as well. If I want to see if a key is expired, if a key is volatile, I can check its time to live. And then it will return that. If a key is not volatile and I call TTL, it will return -1 to let you know that this key is not volatile. Or no, it will return a -2. Because if I try to do the TTL on a key that doesn't exist, it will return a -1. And I may have those backwards. I always forget which way it is. But you can call this on commands that would make sense on. And you can also ask the expiration time instead. And then if you decide a key is volatile and you want to make it non-volatile, persistent, then you call persist. You can use this to make some useful patterns. So a thing that I used with a friend of mine with his startup one time is we went with the never full database. And so he had these articles that he wanted to store cached up over time and then feed up to users. And if they didn't log in for a while, he wanted those articles to fall off the back end and they just get what's more current. And so rather than build anything to do that, we just set max memory, set the max memory policy to all keys least recently used, and then we would add articles by date over time, and then we would serve up the ones that were most recent, and the older ones weren't never accessed, and over time, they would just magically fall off the end. And so we didn't have to do anything to clean up the database. It would just fill up to a certain point and then clean itself up, which is a very convenient pattern. I'm going to skip the demo on this one as well because it's time for a commercial break. We'll be right back after these important messages. So you think Redis, so you think you know Redis is made possible by Redis Stack. Redis Stack is the Redis you know and love, extended with new data types such as JSON, time series, and probabilistic data structures. And it's backwards compatible with existing versions of Redis. It's available on Mac, Linux, and Docker. Upgrade to Redis Stack today. And now, back to our show. Next question. When running open source Redis, what does the following command return? Module unload search. Does it return error unloading module, no such module with that name? Error unloading module, the module exports one or more module side data types, can't unload. Does it return a syntax error? Or does it say okay? Show of hands, who thinks they got it? You're going to guess D, Rustum? It is not D. I did that wrong. Now, I guess I'll have to eat a candy bar. In all fairness, who was going to raise their hand? You know what? We can just eat all the candy bars later. I don't want to take any of these back to the United States. So, I mean, what's the next answer? D is incorrect, sorry. Anyone got any ideas? Oh, hey, well, who do you want to give the candy bar to, Nicola? Yeah. You already got one, didn't you? Yeah. Okay. Yeah, come on up and get a candy bar. And whatever's left over, you can fight over. It'll be great. So the answer is A, error unloading module, no such module with that name. So open source Redis, this is a little bit of a trick question. Open source Redis doesn't have any modules in it. And so if you try to unload one, it's not there. So you get a module not found. But what the heck's a module? Modules are extensions, they're plugins. They're .so files that you can add to your Redis, and they can add new commands to do different things, and they can add new data types you might want to manipulate. They are written in systems-level programming languages like C or Rust or Go. I think you can do it in Zig as well if anyone here is a fan of Zig. For example, I could create a module called Redis image. And what Redis image does is it knows about images in it. So if you put an image in a key, you could have like an image.set, foo, and then the bytes that make up an image. Now, at that point, this isn't any more interesting than a string, because you can put bytes in a string as well. And you could get that image, and still not as very interesting. But you could add other commands like image.scale, and say, take the image that's in foo, scale it by 1.2 times, and put it in the key bar as an image. Now, this is just made up. This doesn't exist. It's just hypothetical. Or image.black and white, and then convert the image to black and white. And so modules let you add new commands and new data structures to do whatever you feel like coding. One of the ones I played around with a little bit is creating a Redis module. This is not publicly anywhere, so don't go looking for it, but where I can load up WebAssembly modules and then from keys in Redis and execute the code. That's kind of neat, right? So you could write modules to do all sorts of things. To load a module, normally you can just do it in your redis.config, or you can do it in the command line. All these options can either be in the Redis config, you can pass them in the command line, or you can set them from Redis commands. So we call module load, give it a path to the module that Redis can see, and we can call module unload if we want to unload that image. If we want to get a list of our modules, we can call module list. And if your module has types, like if I added this new image type, once you've used that, there's no going back. So this is a little bit of a one-way street. If I add an image, my hypothetical Redis image module, I add an image to Redis, and then I save an image in Redis, and then I remove the module. When it tries to load the data back up from disk when Redis restarts, it's not going to know how to parse that key. Its key is going to have an entry it won't know what to do with, and the load will fail. And so the module API, the module commands know that, and so they won't let you unload them. So it's a little bit of a one-way street. Normally something that's configuration, you set it up, and that's just how your database works. There are some common modules out there that Redis has created, Redis the company. We've got a JSON module. This is probably the most relevant to anyone in this room, because in a JSON module, you can put JSON strings into Redis. Now, you could put JSON strings into a string, but Redis JSON actually stores the tree that is the Redis, that JSON document, unless you do JSON path queries and that kind of stuff against it. And you can use those JSON path queries not only to read it, but also to modify it. So it's really powerful. You've probably run into the scenario where you've got some object, some POJO, and you're serializing it to JSON, and you're writing it out to Redis, and then you want to modify a field, and so you got to read it back up, change it, and write it back out again, and you got a window there where an error can come in, where someone else could come in and modify that string out from underneath you. With Redis JSON, you could just change just the part you care about atomically. So it's really cool. We got Redis search, which lets us create search indices against JSON documents and hashes in Redis. A Redis time series, which is sort of it's a time series database in a series of keys in Redis. You got Redis Bloom, which has probabilistic data structures, which is a huge topic. And we've got triggers and functions, which will allow you to do, like if a key gets removed or modified or created, you can trigger JavaScript code to run on Redis itself, or you can just have functions out there that you can call and invoke, and they can modify Redis. So you can run code up there too. These are ones we've created. There are other ones in the community, and these are all part of Redis stack. So we'll skip the demo on that. Oh, I don't have the demo for that. We got, how are we doing on time? I got 15 minutes. Okay. Next question. What does Redis CLI return when you run the following commands? lpush, foo, alpha bravo charlie. lrange, foo, 0, -1. Does it return error, wrong number of arguments for lpush command? B, error, value is not an integer or out of range. C, alpha bravo charlie. Or D, Charlie Bravo Alpha. Raise your hand if you think you know the answer. And if you're over there, I can't see super well, so. Anyone got a guess? Over there, yeah. Shout it out. Yeah, B or D? D as in Delta? That is correct. This is one of those, this is a little bit of a trick question too. Come on down and get a candy bar and a sticker. Because you look at that command up there, lpush, hang on, there we go, foo, and then it's like, I want to push alpha bravo charlie to the left side of the list. And so you're expecting to come out alpha bravo charlie. But actually, you're pushing alpha, and then you're pushing bravo, and then you're pushing charlie. And so alpha gets pushed all the way to the end of the list. So here's an example. So lpush foo alpha, rpush foo bravo, that pushes to the right side of the list. Lpush charlie delta pushes charlie to the left side of the list, and then delta to the left side of the list. So we get this list that's delta charlie alpha bravo. And then we can pop from the list with lpop. And we can use rpop. And so if you've used lists before, you're familiar with these. And then we can lpop multiple items as well. We can say, I want 2 items. So this is simple list commands. Lists, of course, are fantastic as queues, where you push things to the left side of them and pop things from the right side of them. You could push to the right and pop to the left. They'll both do the same, whatever way you want to do it, right? Doesn't matter. But they also make great stacks where you're just pushing and popping from the same side of the list. L is really head and R is tail. It's a doubly linked list behind the scenes. There's a little bit of a pun that I think Salvatore, who created Redis, did. You've noticed, you may have noticed that all the commands in Redis start with letters for the data type you're working with. So like strings are just set and get, but like lists are start with L. All the list commands do. All the set commands start with S. That sort of thing. But because lists and left start with the same letter, he was clever and put R's for things that operated on the tail of the list, instead of having like an R push tail or R pop tail. You can query lists using the lrange command, and you say, I want to start at this index, and I want to end at this index. If your index goes too far, it's not a big deal, and you can just get a proportional list. But most interestingly is, either of these numbers in the lrange command can be negative, and that just means start at the end of the list for your index. And so foo 0, -1 gives you the entire list. I think maybe my favorite command is the lmove command. What lmove does is it lets you move from one list to another, and you can choose the left or right, however you want to do it. And so here we're moving delta from the end of one list and pushing it to the front of another. Probably my favorite pattern with this is you can use this for circular lists. So my buddy I mentioned earlier, I was helping him with a startup, and he's using Redis, and we use this as a task queue. So what you can do is you can use the lmove command, and its source list and its destination list can be the same list. And so if I say lmove foo right left, it will take delta from the right and put it on the front of the list. And you can just keep moving it, and when you move it, it'll tell you the item you got. And so you can just move through this and constantly cycle through tasks. And so you set up like a cron job that goes out and says, every 20 minutes, do one of the things in my rotating to-do list. And if I want to add a new thing, I just add it to the list. So it's kind of a neat little trick. Okay, we got 11.5 minutes left. Next question. What do the following commands return? zadd units 2 alpha 3 bravo. zadd tens 20 bravo 30 charlie. zinter 2 units tens with scores. Does this return bravo 3, bravo 23, bravo 20, alpha 2, bravo 23, charlie 30? Did I see a hand go up? As soon as someone's parsed this out, let me know. You've been nailing these questions so far. And do you have your hand up, or are you thinking? This is awkward. Yes, sir. You say D as in Delta? That is not correct. Who said B as in Bravo? I heard someone say B. That is correct. Come on down and get your candy bar. So, the Z commands are all sorted sets. And so when you do an intersection on a sorted set, you have a question of what do I do with the numbers in those sorted sets? So a sorted set is like a regular set, but they have numbers associated with them. They have a score. This gives them a natural order, which is why they're called sorted sets. And there's a bunch of commands you can operate against them to take advantage of those. And you can, of course, mess with these numbers. You can query them using the Z-score command. You can, of course, query multiple of them with the Z-score command. So give me the score in alpha, or give me the score of alpha, bravo, and charlie. We can increment the score using the zinker-b command. One of our jokes at work is we like to pronounce all the Redis commands, make words out of them. So like set add is sad, the loneliest of Redis commands. And I think my favorite one is zinker-b. It sounds like the name of a wizard in a movie. So you can do a sorted set increment by key foo, value of 1, member alpha, and it will turn that into 2. And you can do z add with instead of incrementing, you can replace the number. So if you add it to the set and it doesn't exist, you have to provide a number and a member name. If it exists already, it will replace it with the new number. And of course, you can do set stuff with them. These are sets. So you can do sorted set add and add your values. You can remove things using the zrem command. And so you just remove the member name. You can get the cardinality of a sorted set with the z card, which will give you the number of items in the set. You can do unions or zunion using the zunion command, the z union command. And you provide the 2 there just is the number of sets that I want to have, and I provide the list of the sets that are in keys. And it will give you a union of those keys, an intersection with zinter, and a difference with zdiff. And this is where our question is, what happens to the score when I do an intersection or a union or a difference? Well, the difference, actually, nothing should happen, but an intersection or a union. So let's say we got the key foo and the key bar. It's Alpha, Bravo, Charlie. This is sort of similar to what we had in the test. You got Charlie, Delta, Echo. Charlie is the one item that is intersecting here. So when we do a union or an intersection, Charlie is the one that we have to apply some sort of process to. And what happens is that by default, it adds them together. So Charlie in foo has a value of 3. Charlie in bar has a value of 4. So if we look at Charlie and here together, it's a value of 7 because it adds them together. However, you can specify that explicitly with the aggregate option, and you give it a sum. And you can give it other options. There's the min, whichever one's smaller, and there's the max, whichever one's bigger. So if we use min, Charlie would be 3. If we use max, Charlie would be 4. So you can add numbers with sorted sets in Redis. This is like math the hard way. And of course, you can query these in a particular order too. So you can say, well, what's the rank of alpha in the set? And it would say it's in position 0. And so if you had like a bunch of usernames and their scores in a video game, you can say, well, what's my ranking? And it could quickly pull that out of the sorted set. You can use zrange to pull out things that are between a couple of scores. You can do, and if it's out of range for the scores, you don't get anything. And you can do zcount and say, well, how many things are between these 2 scores? And if there's nothing there, then score is 0. So we got one last commercial break. I think I'm going to skip the commercial break this time because I'm sitting at 6 minutes, and I do want to leave a little bit of time for questions. So let's go ahead and skip that commercial break. Check out Redis Insight. That was the little GUI I was using earlier. It's actually a really slick tool. You can get it on the Apple Store and the Windows Store, or you can get it from Redis.com. So final question. I've added the following line to my Redis config. Save 1001. What happens when I run the save command? It saves the contents of Redis to disk. It saves the contents to Redis to disk if at least 1,000 keys have changed and 1 second has passed. It saves the contents of Redis to disk if at least 1 key has changed and 1,000 milliseconds have passed. Nothing. Calling save is ignored if save is configured. Yes, sir. That is correct. If you call save, it saves. Come on down and get your candy bar. So in Redis, we have 2 types of persistence. There's the RDB, which is a Redis database. It's a snapshot of the state of Redis that's written out to disk. You can configure it in redis.conf. And the save arguments here, save 3601 means every 3600 seconds, write a snapshot to disk. So every hour, write a snapshot to disk if at least 1 key has changed. Every 300 seconds, if at least 100 keys have changed, every 60 seconds, at least 10,000 keys have changed. And you can configure this multiple times, and so all these rules are applying at the same time. So you can control exactly how much risk you want to take that your data might get lost if Redis were to crash before saving to disk. So you can fine-tune that. You can force this process with the save command, like I showed in the example, or you can use bgsave, which copies the entire contents of Redis in memory, forks it all, and then writes that snapshot to disk, and so it does it in the background, so it doesn't block Redis against continued operations. Save will block anyone from using Redis while you call it, so it's usually a bad plan. So don't call it in production. The other way that you can persist data in Redis is an append-only file. The append-only file, instead of being a snapshot of everything that's in Redis, is a log of all the modifications that have been made to Redis. So every single time a command is sent to Redis that would modify the state of Redis, so a set, a delete, any kind of modification command, then it writes that out to a file and appends, and it's just a big long file. It's a big stack of them. Now you can imagine this file could get big, right? And so you can modify this so that it compact it. So if you set append only to yes, that turns this feature on. You can rewrite these files periodically. There's a rewrite percentage and a rewrite min size. Basically, the percentage says is when it is grown by 100%, issue a rewrite to the append only file. That rewrite will go through and find any redundant things that don't matter anymore. So if I set a key here, and I set it again, and I set it again, and I set it again, it's just going to keep the last one. And if I deleted it after that, it's going to get rid of all of those. And so you can often pull out a lot of the, if you have a lot of volatility in your data, your append-only file can be compacted quite a bit. An important setting on append-only is the append fsync. So you know how in C, when you open a file and then you have to call flush to make sure things are actually written to disk? Right, that phenomenon. This is the reason why we have to eject the thumb drive before we yank it out of the port on our USB, because it's possible there might be an open file and something's in memory that hasn't actually been written to the, I'm going to call it the disk yet, even though it's a thumb drive. Well, Redis is using those same commands in C. It's using fopen and fclose and flush and all those sorts of things. And you can let the operating system handle that if you want by sending append fsync to no. And then the operating system will just say, we'll write out the Redis things whenever we feel like it. You can set it to always, which basically forces Redis to call flush every single time it changes that file. That will guarantee you will lose nothing if Redis crashes, but it also guarantees that your access to Redis is disk-bound, which will slow it down significantly. And the recommended setting is to set it to every second, and it does this just every second. And then you lose at most a second of data. And you can force this rewrite process of the AOF to make it more compact by calling rewrite AOF or BG for background rewrite AOF. And I mention these because a big concern people have with Redis, one of the things that's kind of my job as a developer advocate at Redis is letting everyone know that Redis is a database that's memory first as opposed to explicitly a cache. You can store your data in there, it's safe. You're not gonna lose it. You can control the settings on how you lose it for a single instance of Redis. You can also have high availability with replication so that if a node goes down, the other ones pick it up. You've got clustering. There's a lot that you can use to make a full-featured, robust database platform out of Redis. And I know I said I wanted to wait for questions, but I got 33 seconds. So I'm gonna say thanks for playing, give you some useful links. You can ask me questions in the hallway afterward. It's totally fine. Here's some Redis commands. Redis.io/commands is the most useful page in the world. It's got everything you want to know about Redis. We got Redis stack, which is what I talked about. Just Google Redis stack, you'll find it. There's the Docker image for Redis stack. These are a bunch of pictures that I stole off the internet. And you can play the home version if you like as well. Go to Redis Cloud and redis.com/try-free for a free cloud database, or just get the Docker image, that works too. We got a Discord server, discord.gg/Redis. If you have questions, I'm on there answering questions all the time. I was doing it this morning. And this is a link to Redis Insight, but honestly, get it from the Windows Store or get it from the Apple Store. That's the QR code that leads to these slides if you want to refer to this. So go ahead and scan that. It's totally reliable. It will never give you up, nor will it let you down. And that's what I've got. Thank you very much.